Good afternoon, ladies and gentlemen. My name is Christopher Brent. I am the Meetings and Membership Coordinator with Utilities Technology Council. I'd like to welcome you to today's webinar titled Building Momentum for the 900 PTLE Ecosystem. This webinar today is sponsored by Anterix, and just a few housekeeping notes before we do get started. If you do have any questions during today's webinar, please feel free to submit them using the questions box on your GoToWebinar control panel. And after the presentation is done, we will answer any questions that come in during the presentation. Also, the webinar is being recorded, so if you miss any part of the webinar today for having to leave early or anything like that, this webinar will be available on demand to all registrants today. And now I would like to pass it off to our moderator for today's webinar. Our moderator for today, his name is Mark Poulin. He is with Anterix, and he is their VP of Technology and Engineering. Mark, I'll pass it off to you to introduce the rest of the panel.
Thank you, Christopher. Just trying to advance the slides here. Give me 1 second. Looks like the display is locked up here. Give me 1 second. I'll see if I can restart it. Okay, there we go. Apologize for that. It had locked up. Good afternoon, everyone. I'm Mark Poulin from Anterix, and I'd like to introduce an outstanding group of speakers we have today to talk about the 900 megahertz private LTE ecosystem. Starting, we have Faramarz Maghsoodlou from Qualcomm Technologies. Faramarz is a Senior Director of Business Development. He's focused on leveraging industrial IoT, 5G, and AI for the digital transformation of the energy industry. He has over 35 years of experience in a career that spans energy, IT, and telecom. And he's worked at ABB, Cisco, DNVGL, and Sun Microsystems. Second today, we have Jitender Vohra from Telit. Jitender is a Director of Carrier Relations and Product Marketing for the Americas market. He's responsible for conceptualizing, managing, and launching new products, and he interfaces with major network operators to understand their wireless technology roadmap, technology plans, and spectrum position to drive future product requirements. Third up, we have Warren Westrup from Sierra Wireless. Warren is Director of Business Development. He partners with utility consultants, OEMs, and telecom carriers so they can take full advantage of Sierra Wireless's solutions. Warren has more than 25 years of experience working in the electric and gas utility industry, as well as experience in wireless communications. Finally, we have Brundaban Sahoo from Motorola Solutions. Brundaban is a Director of Broadband Business Development and Sales for the global enterprise market. He has over 25 years of experience in the communications industry, with the last 10 years focused on private LTE for the public safety and enterprise market. Brundaban currently focuses on end-to-end solutions for critical infrastructure verticals like utilities, gas and oil, and mining. All right, so we have a great panel today. I'd like to start off myself with just some introductory slides to start off the conversation. Starting off with, we're talking about private LTE for 900 megahertz. So it's worth starting off with the fact that our 900 megahertz broadband spectrum is new. The FCC report and order specifying the technical service rules and the licensing rules for this spectrum was just approved this year in May by the FCC, then went through the process of hitting the Federal Register and becoming codified the July-August timeframe. And so now it is documented. The technical service rules and licensing rules are documented as law, as they say. And we are at the point now in November where certification of products that transmit and receive in this band is available from the FCC. So the ecosystem is ready to move. So at Anterix, we are working with the OEM community. Certainly everybody that's speaking on this webinar today, as well as many other OEMs, to accelerate the availability of FCC certified devices and infrastructure for 900 megahertz broadband spectrum. So we're doing several things to help with this. First, when they're facilitating the ease and efficiency of getting devices and infrastructure certified in compliance with the technical service rules. So working with the cert house, working through the certification. As I mentioned in the next item, our spectrum is a part of the 3GPP band 8 spectrum. So when you talk about certification, you're really looking at what cert houses do for band 8 in terms of certification, but then looking at a couple of slight differences, which I'll speak to later. But the idea here being to make sure that cert houses are ready and able to perform certification testing equipment. Another thing, we're working with the OEMs to identify and accelerate devices to be certified. So identify what are the right devices to certify and take to market. There's many current products that meet the technical service rules and can pass certification today. Very many of them. It's just a question of which ones do the OEMs want to offer into the market. The ecosystem is currently robust. There are some products that do not meet the technical service rules, and the primary issue behind that is sourced down at the chipset level. It has to do with the fact that the FCC has specified our spectrum for 39 megahertz duplexing, which is the difference between transmit and receive. And in 3GPP for standard band 8, the difference is 45 megahertz. 45 megahertz is not available in the United States, so 39 megahertz traces back to initial narrowband allocations back in the, I think it was the 80s. And I'll speak to that in a little more detail. So obviously we're working with OEMs to ensure compatibility of chipsets, both today and in the future, to enable the ecosystem to grow as we like it, and also working with the OEMs to drive development and make choices on future devices. So in the end, they're focusing on growing the ecosystem. So it's important to remember today there is a large set of devices that work in the spectrum. The ecosystem is robust, and it looks like it will continue to grow over time. Digging into 39 megahertz duplexing a little bit more. As I mentioned, 3GPP specification for band 8, which is the band that 900 megahertz spectrum falls in, is 45 megahertz. The FCC has specified 39 megahertz. The reason that most devices today work with 39 megahertz is there is a capability also defined by 3GPP called network assigned duplexing, where the infrastructure tells the device what frequency to transmit on. So it says, and effectively telling it that it's a 39 megahertz duplexing. This capability is not required, it's optional. It's been there since day one of LTE, back to 3GPP release 8. But there are some chipsets that don't support that capability today. And one of the things we're looking at is enabling chipsets going forward, as much as possible to support that, to ensure that the ecosystem is as large as possible. And I think some of that will come out in some of the presentations as we go forward. And then I've got a nice picture there just showing band 8 as specified by 3GPP, and then showing where the broadband allocation in the US falls within band 8 and showing the 39 megahertz difference between transmit and receive. So that's it for my introduction, and I will hand it off to Faramarz, and he can talk about some of Qualcomm's plans for the ecosystem.
Thank you very much, Mark. It's a pleasure to be part of this panel, give you an overview of Qualcomm's product and solutions for utility networking. Next slide, please. So let me start by giving you an overview of the company. Qualcomm is a technology company with a strong emphasis on research and development. We have more than 130,000 patents, have spent more than $60 billion on R&D through the years. We are best known for our chipsets and mobile products, but we have a broad portfolio of products in addition to that. And we have expertise and know-how in systems engineering and systems architecture, all of that we are bringing to the IoT market. Next one. Next slide, please.
Sorry, it seems to have locked up again. Hang on.
So I continue while you are working on the slide. So as the cell phone transitioned from voice to a smartphone, we developed a powerful system on chips or SoCs to address the needs that they encompass more than just the cellular modem, including communications, compute, and security, many of which are directly applicable to the IoT market, and that is including what we are discussing today, LTE and cellular networking, of course. Mark, if you can please go to one more. Yeah, one more slide. Thank you very much. So these are some of the industries where our products have been deployed, and in particular in energy, we have deployments for advanced metering, and we are targeting broader energy applications in, for example, distribution automation, digital substation, renewables integration, and others. For example, smart sensors for asset health monitoring and performance monitoring, and so on. Our approach in IoT market is to work with large players in each industry to help them adopt these new technologies, and then turn them into reference designs that then can accelerate adoption of IoT for other players in the industry and for the industry as a whole. Now, on this slide, you see a range of SoCs. IoT, of course, is a very vast market. You need everything from simple chipsets for simple connectivity, Wi-Fi, Bluetooth, to cellular connectivity, to integrated applications on a chip with various connectivity options and so on. So we have the whole range of products that we can bring to this market. And all of these have security across the board, hardware-based, and all of them are optimized for power consumption, which is extremely critical for IoT, as you would have to depend in many cases on battery power to keep the system running. Next one. Right, so in our view, the IoT basically has three pillars. The technology pillars of IoT include connectivity, compute, and security. In connectivity, we cover a whole range of wired and wireless connectivities, all cellular connectivities, of course. In compute, we have chipsets that have integrated CPU, GPU, and DSP. And security for us, based on our experience, is all hardware-based to protect the system. But the differentiator for us is that we have it all integrated on one SoC to make it easy to deploy the product and to implement it. Next one. Okay, so coming specifically to private LTE and ultimately private 5G. You know, the advantages of private LTE, of course, for utilities are obvious. Is that total control over the network, local management, security, flexibility in how we roll out different devices for different use cases, and latency control, and so on. So on top of that, there is interoperability with other cellular networks, which is going to be very important. LTE, of course, can utilize different bands. Today, we are focusing on 900 megahertz. It can also use CBRS and others, as you know. But 900 megahertz is a particularly good option for utilities, given its range and robustness characteristics. Next one, please. So with respect to computing, we do have very low power, powerful at the same time CPUs. However, We do have a specialized hardware blocks for other applications that are necessary for IoT, including AI inference at the edge of the network, which is extremely important, and for multimedia applications. Some of these are coming from our mobile heritage and cellular networking, but they are all means whereby a developer community can develop new applications on top of this. Just talking about AI, for example, we are in the 7th generation of our AI chipset, and some of the applications that you see in modern cell phones are powered by our software. In terms of multimedia and using our DSP, we have capabilities for machine vision, and this is particularly useful for utilities in applications such as, for example, asset monitoring or security. With this, of course, we also bring a tool set that have been developed for the broader cellular market to the IoT space. Next one. Okay, so security for us is extremely important. As you can imagine, we have shipped billions of chips to the cellular market, and just given the number of devices and the number of applications and the attack surface, based on our experience, we realized that the best security is foundational hardware-based security, and we have developed that, and we have developed a lot of tools to enable it. And those again are things that we think are very applicable in the IoT space, and especially for utilities. In the shortness of time, we can advance, and we can discuss this in detail perhaps later. But please go to the next slide. All right. So for LTE and 900 megahertz, these are two of our latest IoT chipsets. If you recall the range of chipsets that we have from covering different connectivity options. So it's important to note that this supports both narrowband and full band LTE. We have coverage globally for all markets, supporting different protocols. Some of the applications that you see here have already been deployed. City infrastructure, utility metering, automation, and in the distribution network, smart buildings, wearables, and so on and so forth. Now, the cellular ecosystem is dominated by module-based implementations, and the advantage for utilities is that many of these modules are pre-certified and ready to deploy for the applications that we have. It's a departure from building single-purpose networks and building single-purpose devices, which is great for utilities because they can adopt this and they can grow their capabilities. Now, we have a large ecosystem of partners, module makers, software developers, and so on. You see some of them on the left side of this slide. And we are happy that two of our partners, Telit and Sierra Wireless, are going to be speaking today on this panel. So with that, I hand it off to Jitender to continue.
Okay, thank you, Faramarz. I'm hoping everyone can hear me and see me. And thanks, Mark, for the intro earlier also. Hi, everyone. I'm glad to be here to be part of this panel to further add to the excitement around the 900 megahertz band 39D private LTE ecosystem. So over the next 10 minutes or so, I will explain to you what my company Telit does, where we fit into the IoT solution value chain, and then the type of solutions we provide in case you're not familiar with Telit. Then I will show you a preview of our portfolio of modules that we are tailoring to the 900 megahertz spectrum geared towards utilities. So if we can please move to the next slide, Mark. So Telit is a pioneer in machine-to-machine communications. Today, we are widely recognized as a leading enabler of Internet of Things. So we are at the core of the Internet of Things, offering products and services both for large and small companies that rely on mission-critical connectivity. So like we're talking to everyone on this webinar today. So I realize there may be several people on this webinar that may not be familiar with the IoT landscape. Therefore, I decided to leverage this high-level IoT solution ecosystem diagram, which was created by Beecham Research, as it did a good job of portraying the IoT landscape. So the diagram starts off with the edge hardware all the way to the left, and then it goes all the way down the solution chain to the application and services. So I'm hoping with the aid of this diagram, you can see the footprint Telit has in this space across the different layers of the solution components, all the way from the hardware itself, with our data cards and modules, then with the solutions that we have for connectivity, the solutions we have for platform, and lastly, solutions for application enablement. So I also wanted to touch upon end-to-end security, since Faramarz touched upon that also during his session in the Qualcomm session. So we also have end-to-end solution. So we ensure the end device are hardened to cyber attacks by enabling security that is native to the IoT module hardware, rather than what most IoT security solutions do in the market, which is to kind of bolt it on. So therefore, the IoT endpoint leverages the security benefits of a module secured and personalized at the time of manufacturing. So in example, it's kind of born with an ID with credentials and SIM functions embedded into a trust zone. So this kind of happens before we even ship it out from the manufacturing facility. Bottom line, the takeaway of this slide is that we're very flexible. You can just buy our modules, you can just buy our connectivity, you can just buy our platform separately, or we can bundle them together as an integrated end-to-end solution, thereby reducing the complexity, the risk, the time to market, and cost, versus trying to engineer your own homegrown projects. So at Telit, we view ourselves as an enabler for those of you that are building end products that will be part of the Anterix Band 39D spectrum. So if we can please move to the next slide. So let's talk about our modules for a minute. So Telit started off as only a module manufacturer, similar to what other IoT pioneers did. So from a module perspective, we offer 4 solutions in 4 key areas. Let me touch upon cellular IoT. So by this, I mean like 2G, 3G, and from an LTE perspective, NB-IoT, Cat-M, Cat-1, up to Cat-4. Then from a cellular broadband, what I mean by this is Cat-11, Cat-18, and even 5G. So we also focus in on GPS and positioning modules. Lastly, Wi-Fi and Bluetooth. So, but one thing for sure, majority of our existing business is based upon cellular. With that, I will move to the next slide and kind of focus a little bit more on our cellular IoT modules. So this slide does a good job mapping the various cellular technologies shown in the first column to our family of modules, which are shown in column 2, 3, and 4. It also shows which form factors are supported by all of our modules. So let's look at a column 2, which consists of our 310 family modules, and the column 3 contains our 910 family-based modules, and the last column contains our data card family-based modules. So the 910 family has been our flagship for a very long time, as majority of our customers have been using this family of modules. This form factor covers a broad number of technologies from 2G, 3G, NB-IoT, Cat-M, up to Cat-4. The 310 family is our newest and the smallest form factor we offer. I consider this to be our new decade product. It is perfect for customers that want smaller form factor. It's about quarter of the size of the 910 family for applications where size is a premium. So the last column, which is our data card modules, are available in mini PCIe or an M.2 form factor. So as we head towards 5G, the M.2 form factor comes into play. So as you can see, we have a very broad portfolio of cellular modules here at Telit. I kind of put a box around all of our modules that are based upon the Qualcomm chipset and that will be supported on the new Anterix's 39D spectrum, as this is most important to this group of people on this call. Our G series of modules on the bottom row within the rectangle box is based upon the Qualcomm MDM9205 chipset. And then all the other modules within the rectangle box are based upon the Qualcomm MDM9207 chipset. So just so we're clear, the ME310 G1 series support Cat-M and NB-IoT, where the LE910 series is a Cat1 module, where the LE910C4 is a Cat4 module. So now, if we can move to the next slide, what I'll do is get a little bit deeper on the modules in the rectangle box. This slide here summarizes our private LTE 39D surface mount modules, as well as our data card variants. So we're very flexible. We offer very flexible module options. So on the left side, there's a picture of our surface mount modules that can be soldered down. Or as seen on the right side of this slide, you can plug the 910 family of modules in the application with the standard mini PCIe Express card. So if we want to talk a little bit about size, on the bottom, the ME310 G1, we offer that in 2 sizes, of which the smallest is a 13 by 14 millimeter. And then our 910 series is a 28 by 28 millimeter. So about 3 times about a quarter of the size of the 910. So as I mentioned in the previous slide, our 910 family, we have it in a Cat4 variant, Cat1 variant, LTE-M variant, and an NB-IoT. These are all pin-to-pin compatible between each other, which results in a very smooth evolution path. We also offer on both the surface mount modules and the data cards, very flexible band support. So in addition to Anterix's band 39D, we also support, public operator network bands. Both the surface mount and data cards have a smooth evolution path, as I mentioned, from Cat4 to Cat1 to LTE-M and NB-IoT. Then on the bottom, I wanted to highlight our One Edge and App Zone. Those are tools we developed to simplify your integration and accelerate your time to market. So the One Edge is basically our device management service, and it comes with lots of pre-integrated stuff like a zero-touch onboarding, pre-provisioned certificates, security features, App Zone environment. So our goal is really to simplify things and time to market for our end customers. So I just wanted to also add that we support GNSS to help you know where your devices are. So if you have one meter in one house and another meter located at a different house, and the bills happen to be swapped with GPS, you'll be able to quickly fix that problem. So again, we view ourselves as an enabler for those of you that are building end products that will be part of the Anterix Band 39D spectrum. So with that, this concludes my portion of the presentation. I want to thank you all for your attention. Please feel free to reach out to me directly if you have questions. Now I want to hand it over to Warren to talk about Sierra Wireless offerings. All to you, Warren.
Thank you, Jitender. Mark, you can advance the slide. There you go. Oh, yeah. So again, my name is Warren Westrup. I am business development over the utility and commercial markets at Sierra Wireless. Hopefully most of you know who we are, but just real brief history. We were actually started, for those that don't, we were started in 1993. We're number one when it comes to modules and gateways. We're in 80% of the top utilities here in the United States, and we're also a global company. So we've been in the business a long time, and actually the utility sector is one of our key verticals, key customers that we work with. You can advance the slide, Mark. So, I've been in the business for quite a while. Private LTE, I actually worked for a utility at one time. The benefits are really big for utilities. They always want to, critical infrastructure, they always need to own and operate, or they prefer to own and operate their own network. When you look at the business case, obviously cost is a big one. As far as reoccurring charges is big, but as you add more and more, what we're seeing with distribution automation, with more IEDs, fault sensors, and all that sort of stuff going into the grid, the amount of points, the IoT points have increased significantly. So that can really affect the cost of the OpEx, which we all know is a big hitter for a utility. Second of all is coverage, right? Optimize the coverage per your particular service area. The commercial carriers, they built out their networks to cover consumers. We all know that. The utility needs something different because not always where they need coverage is where the most people are. And then obviously reliability and performance. especially in hot zones when you think about, the Gulf Coast area and things like that where hurricanes come in, having that reliability and be able to have that own performance, it's key to being able to, having your own private network. And then obviously uptime. You just really know when, you don't know when the commercial carriers are going to take something down. I know they put a lot of redundancy in their network, but, as far as maintenance and things like that, they got to do it when they do it, and they don't really call the utility to let you know. And then security, being able to add more security to the end device, things like IPsec, MPLS, these are all critical things as we know for the utility sector. And then the private network also allows you to have application variety. One example is a utility that we're working with. They want to be able to use their private network and use drones. Well, that's a whole different application. The carriers, even though they talk about drones, sometimes that network needs to be fine-tuned, optimized for being able to support that kind of thing. So with that, Mark, you can take it to the next slide. And the business case is strong for sure. Back years ago, when I was with Motorola, we were selling something called private IDEN. And, we worked on the business case, being able to leverage as many applications as we could. For those of you who remember IDEN, great technology, but the bandwidth wasn't, nothing like what we can do now with private LTE. So distributed power generation, being able to do things and renewables, being able to do things like direct transfer trip over the private LTE network, that can be done today. Obviously FLISR for self-healing grid and those kind of things. Distribution automation, we all know about smart meters and being able to do that. And then demand response, and then the maintenance service, push to talk. There's a lot of legacy systems that are push to talk, and then mobile data as well. And then we see the EV chargers coming in. So the business case is really strong. When you add a lot of utilities, not only are they electric, but they also have gas operations. So when you add those to the mixture as well, it even strengthens the business case even more. So really good for the market, really needed as well. And I think the financials will prove themselves out. Mark, you can go to the next slide. So, as far as we look at Sierra, I mean, this is great. We're so happy that this happened. 900 megahertz is much needed. When I started my wireless career back at Motorola 20 years ago, we were dealing with 25 kilohertz channels, 25 and 12.5 kilohertz channels. And we were doing mobile data over those things and push to talk. But, as the technology increased and the technology advanced, there's just so many other things that can be done now. And, that's where, the broadband, the need for this kind of spectrum, it's just so important. And, again, at Sierra, we really embrace that, and we're glad it's happening. It helps them, like we've talked about before, helps the utilities face these connectivity needs to market growth, meters and distribution equipment. It allows them to be more secure, be able to do their broadband connectivity for all this grid modernization, digital transformation initiatives, and then meets the coverage and reliability aspects that a critical infrastructure provider like a utility needs. So with that, thank you. I'm going to hand it over to Brundaban and with Motorola to take you through his slides. Thank you.
Thank you, Warren. Good afternoon, everyone. I'm glad to be part of this panel to discuss the 900 private LTE ecosystem. So far, you heard about the readiness and the ability of the spectrum, then to the chipsets, to devices, modules and the devices, right? So as most of us know, today in USA, for the critical infra verticals such as utilities and other enterprise verticals, right, there are largely two main frequencies being discussed, right, for the private solutions, CBRS and this 900 megahertz 39D, right, and more to come down the line that we expect, right. Can you go to the next slide, please? So with the momentum building for the private LTE in the 900 meg spectrum we're just talking about, let me give an overview of Motorola's end-to-end private LTE solution offering centered around CBRS and this 939D spectrum, right? That can handle all of the voice, video, data, and the IoT use cases needed by the utilities. So this is a very high-level end-to-end solution overview that Motorola working towards to offer. Just to start from end user application perspective, from the right topmost box, the main use cases which is driving the need for the private LTE, at the reliable backhaul for the AMI, distribution automation, assets, then FLISR, volt and wire control, and the SCADA IoT in general, and then how that integrates it back to the customer's existing outage management system, ADMS, and network and the device management system. So from a workflow perspective, starting from the left, you see there are different type of the field devices, could be mobile or fixed, supporting to these use cases. There can be potential portable mobile devices supporting voice and data over both 900 and CBRS as well. Today we are talking about just Qualcomm announced 2 chipsets, right, mainly for the data applications. And then there would be devices that may not have the direct communication capabilities, such as the legacy DA assets, camera, meters. They can use a modem gateway, as you see on the left, that can aggregate the data from multiple field devices or assets, either wired or wireless, and send over either 900 LTE or other backhaul infrastructure systems. So as you would see, FCC ruling that Mark told you earlier, it allows high power transmission both from base station and devices as well. Base station can transmit up to like 2400 watt ERP effective radiated power, and the fixed mobile devices up to 10 watt ERP, and portables up to 3 watt. So Motorola is developing a portfolio of the smart IoT data modem gateway products. I'll talk about it in detail shortly. Motorola is also developing a very high power eNode B system for 900 private LTE. So both device and eNode B are in active pilots now. And moving to the right, we have the flexible LTE core offerings, whether it's completely on-prem, fully hosted versus a hybrid or distributed deployment model, right? Where hybrid means the control plane can be in the private cloud, and user plane traffic stage to the customer enterprise network in the kind of on-prem, the packet data gateway, right, for all the applications. And then eventually all the field data from the left integrate into the many of customers' existing backend management systems. So other key aspects, the differentiating aspects to add from our portfolio perspective is those 3 blue boxes on the right, video security and analytics suite. In this context, this is all about how to communicate analytic and the smart video over a limited bandwidth pipe, such as this 900 3x3 channel bandwidth, right? And then our market-leading MCPTX suite, mission critical push to voice, video, and the data, 3GPP standard-based MCPTX offering, and along with the interop functionality, which is pretty key. Another most important requirement that we do hear from most of the utilities asking for LMR to LTE migration, right? So Motorola, from legacy perspective, market leader in LMR. So as the demand for more and more data grows in the smart grid applications and then the market, right? Customers keep asking, what is our migration story, right? So to support that, as you can see the bubble on the right bottom on the chart, we call it the critical connect gateway, that really kind of provides a call interoperability between LMR type, like it could be P25 or DMR LMR, to different type of the private or carrier LTE, right? So essentially the LTE core interface with the critical connect gateway, providing this flexible interoperability across different private and the carrier systems. So this is an overview on how MSI is coming up with the end-to-end solution offering for the 900 private LTE. So as this webinar more focused to the device-centric part, so let me give an overview of the Motorola broadband and the IoT device portfolio targeted for utilities. Next slide, please. Thank you. So let me start with those 3 fixed IoT gateway devices on top, currently targeted for our 900 private LTE system. The H4200 is standard power and 4600 is the high power on the left. High power supporting up to like 10 watt ERP. So The need for this high power transmit, it makes sense as most data use cases, as we see in our distribution automation and smart grid applications in utilities, right, are uplink focused from device perspective. So high power provides a much higher uplink throughput at the cell edges if you compare at the same cell edge compared to a standard power device, which is at like 200 milliwatt power. So this helps in connectivity reach out to the last mile remote data security assets, right? So pretty much kind of giving a coverage to very deep rural areas. That's where it kind of comes as a key benefit. So this edge device is a fixed IoT modem gateway, providing backhaul over multiple LTE for utility data applications. It can support up to 3 LTE modules for concurrent communications, whether CBRS, 900, Cat-M, Cat-NB, along with GPS and Wi-Fi as well. It can support a combination of private LTE, carrier LTE as well, including the FirstNet fallback, dual SIM, dual serial, dual Ethernet, it's pretty flexible and customizable SKUs to order. Comes with a robust edge computing platform for Motorola app integration down the line, which will add more and more differentiation down the line as well. It's compact and secure with IPsec, built-in VPN, FIPS 140 level security, level 1. Now it can go up to level 2. We have definitely, Motorola has the products with the level 2, so we can expand that. It has gone through all the regulatory compliance, all the required certifications, including the Class 1 Div 2 and the IEEE 1613 as well. The one on the third one, the H2200 and the 2600, I'll talk about that first. So those are the scaled down version of the H4200 or 4600. The same platform functionality, but with a single LTE modem or module, dual SIM, single serial, single Ethernet. So based on the module type, it can support like 900 with carrier fallback, CBRS with carrier fallback, and can have Cat-M, Cat-NB as well. The middle one is a unique device. We call it as MC Edge. It's supporting the convergence of simultaneous communications over LMR, private or carrier LTE, and the LoRaWAN. We keep hearing from our utilities that how they can leverage existing LMR infra where they have made the investment for years, right? Especially for some of the mission critical asset monitoring triggers and alerts, or in general, assets that require very low data communication. We understand LMR is good for the voice, but it can also do some limited data. And we understand from the infrastructure perspective, it's a very mission critical system, right? So that's where it's getting a lot of attention. So main purpose is really to reduce the OpEx, right? Cutting down the monthly carrier subscription fees that customers will end up paying to the carrier. So the idea is to use the LMR as the primary network for the limited data assets with carrier cellular as the fallback. And once the 900 private LTE infrastructure is built in, we can use 900 private LTE as the primary with LMR as the fallback, right? So that the OpEx part is completely cut down. This device also can aggregate multiple LoRa sensors and backhaul over either LMR or private carrier LTE as well, right? It has a built-in RTU supporting both legacy and the new IoT protocols, and also custom programming capabilities. So another unique differentiation, right? It really supports the very high assurance security with FIPS 140 level 1 can go to level 2. So that kind of provides a very high reliability comfortness to our customers, right? And at the same time, in general, device providing a backhaul communication redundancy. So these three are currently using the Sierra MC7455 module for 900 private LTE. As discussed earlier, right, once the new module ecosystem is ready with the Qualcomm 9205 or 9207 chipset, these devices will be upgraded with those modules in about Q1, Q2 timeframe of next year. So beyond these three devices, Motorola also offers other purpose-built devices for utility customers. So really quick on the bottom row, you see SLN 1000, Evolve. These are two CBRS portable devices. SLN 1000 is a voice only. and Evolve is a voice plus data Android device, pretty ruggedized, dual SIM with carrier fallback. Lex L11, it's Android device with carrier and FirstNet. Talk 100, it's a voice only portable, right? And Talk 150, it's a voice only mobile for carrier and potentially can support 900 LTE down the line. So more to come on that. So right top is a multi-device LTE LMR convergence solution, something called as Smart Connect. So the concept of like always staying connected with the voice services. So we'll be happy to discuss the details on this Smart Connect solution, right, for those interested. Next slide, please. So just to summarize what the benefits are with the Motorola 900 private LTE system. So with the high power infra and the devices, right, it helps to reduce the LTE site count compared to using the commercial LTE solution. We have done a lot of the coverage modelings, right, and working with multiple customers, and we are getting consistent results with that. It leverages the existing LMR site infra and hence reduces the overall TCO and the OpEx. And the most importantly, more than just the high power, our 900 LTE station is designed to provide uniquely optimized mitigation and with a very sharp out-of-band emission mask filtering to address the LTE LMR RF interference, right? And which kind of enables the simultaneous LTE and LMR operation within the same big 900 5x5 big band, right? Because you have 3x3 broadband, and then you have 2x2 narrow band as your next neighbor, immediate neighbor, where you can do it simultaneously. So that's a huge one, right? I mean, just as an example, in your service territory, even if you may not have your LMR operation in that 900 2x2, right, next to the at the side of the 3x3, there could be other incumbents, right, in those 2x2 narrowband space operating while you are doing broadband in this 3x3. So it's very important to have a system that can give you the enough safeguard to your broadband operation, right? And even if you have your narrowband in the 2x2, it's very comfortable. You can do both at the same time. So besides the unique differentiation on the 900 private LTE, just to summarize, right, as we discussed, our solution has the flexible LTE core offering, purpose-built device portfolio with more devices to come down the line, right? We keep working on that. LTE LMR interoperability, and the last important point is the Motorola being the turnkey solution provider with tons of pre-filled and in-field system integration experience, right? Including a full managed service suite and the capabilities. So with that, I'll pass on to Mark to proceed with the Q&A session. Thank you.
Thanks, Brundaban. All right, why don't we start with some Q&A? Brundaban, I'm going to keep you on the speaking here because you got some really good questions came up as you were speaking that are quick to answer. There's a great question on how Motorola will be selling your solution through dealers or directly through Motorola direct sales force. Do you have any comments on that? And then another question was directly related to that, which is how does someone get a budgetary quote?
Absolutely, absolutely. So right now, our 900 private LTE system is a direct sales only. Please feel free to reach out for any kind of budgetary needs that you have. I think Mark or our UTC moderator can share the email address, right? Feel free to reach out, right? Any of the questions that you have asking for any budgetary.
All right, thank you, Brundaban.
Sure.
Another question for Jitender from Telit. In one of your slides when you were discussing the modules available for 900 megahertz, there was a brief reference to support of public carriers and global operators and things like that. I was wondering if you could make some additional comments on on support of other bands and other operators on those chips.
Yeah,
or
thanks.
module.
Yeah, thank you, Mark. Yeah, so obviously we're supporting the band 39D, but our modules, the ones we talked about, both the 9205 chipset base and the 9207, will have a global carrier band supported also in the same module. So that will be supported out the door.
A comment I would make on that is that's important to many, to many customers, because quite often the devices might be used on other bands in addition to 900 megahertz, where those capabilities are critical. All right, and a question for Faramarz. From as Qualcomm is obviously incredibly familiar with the evolution of cellular technologies and the very short life cycle and the quick upgrade process that comes along in the cellular industry, I was wondering if you could comment on how a cellular technology like LTE, how that can map to utility need, which is more of a longer term deployment and longer cycle time type deployment scenario. So wondering if you can make some comments on that.
Yeah, okay, sure. So first of all, in terms of product support, obviously utilities need a long life cycle for the deployments, and it could be potentially a concern that the cellular technology is evolving so fast, and if they invest, would they have to face obsolescence in their investment, in technology investments? So on the product side, from Qualcomm perspective, we of course support just a longer life cycle and software support for the product that to begin with. But to add to that, the fact that we are moving from purpose-built proprietary networks to something that's a standards-based. To begin with, it gives you access to probably the largest ecosystem of vendors and suppliers and developers. And you can now be in full control of the transition in a private network, so that as different cellular technologies evolve, you can decide when you want to move on. The other thing that's very important here is that up to this point, many of our networks, we were stuck with devices that were purpose-built, and sometimes vendor support was questionable and so on. The thing with cellular, as we have seen in the evolution of cell phones and as we go into 5G, is that many of these future capabilities will be software enabled. So it's not a rip and replace, but it's rather capabilities that can be added to the device as you go. So all of these things should give utilities assurance that they are not going to be stranded with assets that are going to be left behind, because now we go to 4G, 5G, 6G, and whatnot. Because when we get to actually even 9205 that we talked about briefly here, it's upgradable to 5G, software upgradable. So we are talking about a transition that is more managed and controlled. So that should give some comfort and I guess assurance that this is not like the old transitions, that this is more managed.
All right, thanks, Faramarz. Warren, it's here. I'm going to pass kind of the same question along to you, given that Sierra has, a lot of experience on the private system side, and your comment on perhaps from a Sierra perspective on supporting, long deployment times and being able to support
Sure.
for multiple cycles.
Sure. No, I mean, exactly. I mean, I've got to, say pretty much follow through what he said from Qualcomm. Absolutely. I mean, the longevity is really important. We know that utilities, they expect to get 10 to 15 years, if not more, for the assets that they deploy. So, part of the upgradable capability is, when you think about narrowband LPWA is what we call low power wide area, all those are really considered 5G technologies. So what that does is it really helps them, prolong that future of their investment of what they're going for sure. So it's a great upgrade path. They're not really boxing themselves into a corner by going this direction, because they still have that capability in the future.
All right, great. Thanks, Warren. Another question for Brundaban. You mentioned some of the advantages of the high power aspects of your offering with site count and total cost of ownership. Are there any particular benefits that tie to, you were mentioning the LMR to LTE migration You touched on that. I was wondering if any of that ties with, along with the high power aspects of your offering.
Yeah, absolutely. Good question, right? So as we know, LMR in general is it transmits at much higher power, both from the base station standpoint and also from the device standpoint, right? It's even much higher than the initial device that's allowed for the 939D, right? So when we talk about this high power eNote B along with the high power device, eNote B transmitting at much higher power with a specific channel bandwidth, improving the coverage reach out, right? So it's kind of leveraging the LMR footprint, right? So how can we leverage the existing LMR sites so that we can cut down the TCOs of building the new sites with the standard power LTE base stations, and at the same time, how we can leverage a lot of the site-specific infra in terms of the backup generator, because we are talking about the critical infrastructure, not the carrier, right? So how we can take care of some of the hardening piece of the base stations that goes around the LMR side, how we can piggyback on that while we are adding on a high power LTE base station to the same site as LMR. So with the many simulations we have done so far, LTE high power, sometimes it depends on the terrains, right, and the geography region. Sometimes it kind of outperforms the LMR 100 watt, right, and sometimes depending on whether it is mountains or terrains, right, we have to do some coverage optimizations, right, to come up with as close as what we can do with the existing LMR sites, right. And also the other good thing is that having the high power on the device side, it really kind of improves the uplink margin, providing a higher uplink throughput at the cell edges compared to a standard power device, as we discussed, right? So with that, you can think of like higher data asset applications at the edge, or a scenario where in the remote areas there could be very handful number of assets, but you don't want to build out there won't be a need to build out a new site or additional site, like if you go in a standard solution way. Rather, you can just extend it with our high power and get the connectivity to the last mile assets, right?
All right, thanks, Brundaban. I think we are reaching 3 o'clock, and I think we've gone through all our questions. So I think we have that concludes it for today's webinar. Thank you very much, everyone, for attending and joining us, and thank you all the presenters. I think this was very, very interesting.
Thank you, everyone.
Thank you very much.
Thanks, everyone. Thank you.
Thank you.